In this example, the signal xt is given and we are asked to determine its fundamental frequency as well as its Fourier series coefficients. As you know, any periodic continuous time signal can be represented by its exponential Fourier series. The Fourier series expansion of xt can be written as follows. Our goal is to determine the coefficients ak together with the fundamental angular frequency omega 0. Let's begin by rewriting the given signal in exponential form. The constant term can be written as 2e to the power of j 0 omega 0 t, since e to the power of 0 is simply 1. Next, let's rewrite the cosine term. Using Euler identity, cosine theta is equal to 1/2 e to the power of j theta plus 1/2 e to the power of minus j theta. Therefore, cosine of 2pt over 3 can be written as 1/2 e to the power of j 2pt over 3 plus 1/2 e to the power of minus j 2pt over 3. Now let's rewrite the sine term. Using Euler identity, sine theta is equal to 1 over 2j multiplied by e to the power of j theta minus e to the power of minus j theta. Since the sine term is multiplied by 4, the result becomes 2 over j times e to the power of j5 pt over 3 minus 2 over j times e to the power of minus j5 pt over 3. Now that every term is written in exponential form, the next step is to determine the fundamental angular frequency. Notice that the frequencies appearing in the signal are 2p over 3 and 5p over 3. To obtain the fundamental frequency, we factor out the common factor p over 3. This leaves the integers 2 and 5. The greatest common divisor of 2 and 5 is 1. Therefore, the fundamental angular frequency is p over 3. Now we compare each exponential term with the standard Fourier series expression. The constant term corresponds to a0, which is equal to 2. The exponential term e to the power of j 2pt over 3 is equal to e to the power of j 2 omega 0 t. Therefore, a2 is equal to 1/2. Similarly, a minus 2 is also equal to 1/2. Next, exponential term e to the power of j 5pt over 3 corresponds to a5, whose coefficient is 2 over j. Since 1 over j is equal to minus j, this coefficient can also be written as minus 2j. Finally, the exponential term e to the power of minus j5 pt over 3 corresponds to a minus 5, whose value is positive 2j. In this example, we reviewed how to express trigonometric functions using Euler identities, determine the fundamental frequency, and calculate the exponential Fourier series coefficients of a continuous time periodic signal. If you found this tutorial helpful, please like the video, subscribe to the channel, and stay tuned for more solved examples on signals and systems.